So last class we were looking into ladder friction. Ladder friction, so basically the ladders, all the ladders that we use work because there is a friction. Friction allowed to മാത്രമാണ് ladder working. Friction ഇല്ലെങ്കിൽ എന്ത് പറ്റി? Ladder വെറുതെ ഇങ്ങനെ വെച്ച് കഴിഞ്ഞാൽ അതിന്റെ weight കൊണ്ട് it will just fall down. Okay, it is a friction that is keeping the ladder in place. So we have seen some problems. I think we have given assignments also. Assignment seen some of the assignments. Some people are yet to finish the assignment. I don't know why. So those one right. Bibin Jacob. No.
Yes, sir.
The assignment is there.
Are you kandilla?
Kandilla no. Assignment ella class nil ullada
ഞാൻ ചെക്ക് ചെയ്ത് നോക്കി. സാറേ മെയിൽ നോക്കിയില്ലായിരുന്നു.
നമുക്ക് എല്ലാ ക്ലാസ്സിലും അസൈൻമെന്റ് ഉള്ളവരെ അറിയത്തില്ലേ?
മറന്നുപോയി സാർ ആ കാര്യം. ഞാൻ അന്ന് പിന്നെ മെയിൽ നോക്കിയില്ല.
ഇന്നെ തീർക്ക് കേട്ടോ.
ആയിക്കോട്ടെ.
There is a lot of people who are yet to finish. Anik Tom, Aslam, Abhishek, Vinod, Elias, Anandu, Arjun Ajimon, Harishankar Sanjeev. ഇത്രയും പേര് സബ്മിറ്റ് ചെയ്തില്ല. ബാക്കി എല്ലാവരും സബ്മിറ്റ് ചെയ്തിട്ടുണ്ടോ? Finish it today only. So നിങ്ങളുടെ ഈ അസൈൻമെന്റിന്റെ സബ്മിഷൻ മാത്രമല്ല ടൈംലി സബ്മിഷൻ മാർക്ക് ഉണ്ട്. So mostly I think this week only I'll give you ഇതുവരെയുള്ള മാർക്സ് ഞാൻ ഡിസ്പ്ലേ ചെയ്യാം. So then you will get an idea. Okay. Right. So this is ladder friction problems are നമ്മൾ ചെയ്തുകൊണ്ടിരുന്നത്. Today we will start a new module. So basically friction, there is a lot of problems that we have to see. അപ്പം എന്താ ചെയ്യുന്നത് വെച്ച് കഴിഞ്ഞാൽ ലാസ്റ്റ് കഴിഞ്ഞ ഒരു 5-8 കൊല്ലം KTU വന്നിട്ടുള്ള പ്രോബ്ലംസ് ഒക്കെ ഓരോന്നോരോന്ന് ഞാൻ ചെറിയ വീഡിയോസ് ആയിട്ട് I'll upload in Moodle. Okay. So after uploading, I will put in the Teams also so that you can go into that and look. Okay. അല്ലെങ്കിൽ ഞാൻ യൂട്യൂബിലാണ് അപ്ലോഡ് ചെയ്യുന്നത്. ഒന്നെങ്കിൽ യൂട്യൂബിൽ നിങ്ങൾക്ക് പോയി നോക്കാം, അല്ലെങ്കിൽ മൂഡിൽ ഞാനിട്ട് മൂഡിൽ നിങ്ങൾക്ക് നോക്കാം. സോ റെഗുലർലി മേക്ക് ഷുവർ ദാറ്റ് ഞാനൊരു തരുന്നൊരു പ്രോബ്ലം നിങ്ങൾ യു നോ ഹൗ ടു സോൾവ് ഇറ്റ്. ഓക്കെ. അല്ലെങ്കിൽ നിങ്ങൾ അതിന്റെ വാല്യൂസ് നിങ്ങൾ തന്നെ മാറ്റി നിങ്ങൾ സോൾവ് ചെയ്യുക. Or I will weekends I will start giving more assignments from now on. Okay, because in class you have to make sure that the more ningal problem count etra problem ningal cheyyunnundu. Ningal problem ഒരുപാട് ചെയ്യുന്ന എത്ര കൂടുതൽ പ്രോബ്ലം ചെയ്യുന്ന അത്രത്തോളം കൂടുതൽ ചാൻസ് ആണ് നിങ്ങൾക്ക് മാർക്ക് കിട്ടാൻ. കോൺസെപ്റ്റ്സ് മനസ്സിലാവും. മാർക്കിനെക്കാട്ടി ഇമ്പോർട്ടൻറ്റ് we have to understand the concepts. ഇത് മുന്നോട്ട് പോകുമ്പോൾ we are going to use all these concepts. Okay, right. So now today's class what we will study is a new concept called moment of area. I don't know whether you have studied this in your 10th, 12th. So ഞാനൊക്കെ പഠിക്കുമ്പോൾ it was there in 12th, moment of area and centroid. I'm sure that it was there for you people also. So what is moment of area? Moment of area is defined as, so let's say we have an arbitrary area here. Arbitrary area under some area is there. Okay, and we also have two axes. So some reference axis can be anywhere in any orientation. I'll call this axis as x-axis. I'll call this as y-axis. Okay, perpendicular axis. Now this area can have a 2D figure. A 2D figure it can have two moment of area. So number of force in the moment endana. Moment of force is, so basically we have a force. Let's say we have a moment about this point. The magnitude of force is this, and the distance is, let's say, d. Okay, so moment of force is equal to force times perpendicular distance. Same on a moment of area. Moment of area. So let's say I will take a small arbitrary area here. So I'll take this area. Okay, each area. I'll call this area as dA. Okay, if moment of area, I can again this moment you can find in with respect to any axis also. Force. So let's say more general, some force is there and some moment is there. Two axis is there. Axis. we can find moment in this plane or moment about this plane. അതായത് നിങ്ങൾക്ക് ഈ ഫോഴ്സിന് രണ്ടായിട്ട് സ്പ്ലിറ്റ് ചെയ്തു. This is the y component, this is the x component. You can also find moment about this line, like a point here. About this axis, we can find moment about this axis also. Let's say about this axis, e component into perpendicular distance. This component into this distance will give moment about this axis. E force in the e axis, e axis, e component into this perpendicular distance. Multiply. Okay. Similar way, this also you can have moments. We can define moments in any axis. So let's say we define moment about y-axis. So I'll write because of the small area. So I'll call this as dm about y-axis equal to my area into perpendicular distance. So this perpendicular distance, I'll just give some arbitrary distance. So let's say I'll call this distance as x, small x. I'll call this distance as y. Okay, so this is x times dm. So about y it is area into perpendicular distance. What about moment about x? So moment of area about x. So the concept force and moment in area moment concept. So you're just learning a new concept. Okay, so don't look for this physical meanings. The physical meaning in the application so x about x axis it is equal to area into distance. So distance is okay. But the total full area moment you take different small areas, areas add. So calculus adding is same as integration. So my moment about x will be equal to integral of y dA. Okay, and moment about y will be equal to integral of x dA. Okay, so this is a new concept that you're learning. Moment of area to moment. Okay, so remember this. You can quickly draw a small circle and derive it. This is the idea. This is the moment of area. Okay. Now this has many applications, but one of the applications is to find the centroid of a body. Now, what is the centroid of a body? Centroid. So what is centroid of the body? Centroid is a body is basically a body. So again, centroid of body, we can also draw a parallel with forces. Forces force, friend force, mono force. These forces we can assume to be acting in a single point. Forces we can act at a single point. So basically, this is equivalent. These forces we are assuming it to be acting at one point. So similarly, we can assume this entire body we can represent this entire body in a single point. I don't know what is that point. Let me say this is a point. Okay, the entire body area I can represent in a single body, such that the moment of area of this entire body will be same. Body. So let's say I will draw an equivalency. Equivalency at more easy. So this I'll remove. So this. So remove this. Okay, so moment about x of this and moment about x of this. So let's say the area of body is A. Okay, so I'll assume this entire A is concentrated at this point. Okay, this body area A. Area full, I am assuming it to be concentrated at some point. So this point is, let's say, XC and YC. X is for centroid and X coordinate, YC is for centroid and Y coordinate. Okay. So moment of this area, this is integral of y dA. Moment about y equal to integral of x dA. So this is same as a times x by c. A times by c. This area. So let's say this point area, same area, but it is at location at one point. About x axis the moment and area into distance. Distance is yc. Okay. About y axis area into distance. That is x. Okay. So this both are same. Same or equal. Equal. Okay. Point centroid. So centroid is nothing but we can represent the entire area to be at a point. That is one point. So that point is centroid, such that the moment of this area about one axis is same as moment of the area in the centroid about the same axis. The moment of area will be same. Only thing is the entire area we are assuming it to be constant at that point. Okay, so I hope this is clear. If I equate these two, I'll get integral of y dA equal to a into yc. MXs, okay. So that means yc equal to integral of y dA times a. Similarly, my xc is equal to integral of x dA upon a. This is the formula for centroid. I told you it's random same on the so this equation and this equation I equate. From ayc equal to y dA. So that means my area is equal to, or yc equal to, centroid location is equal to integral of y dA upon a. Okay, x in the integral of x dA upon a. Right. So I hope this is a simple concept. Particular concept. So regular shapes in the we have to find centroid. So we now next aim is to find centroids of regular shapes. And composite shapes. Okay, so we will do one regular shape, but a regular shape which then we will do a composite shape also. So okay, so we'll do some. So let's say rectangle. We'll take a rectangle. So I'll take the easiest one. This is a rectangle. So let's say this is the width. This is the depth. Okay, and I will also construct an axis. I will put an axis here. If not, an axis it should be easy. Right. So this is my x-axis. This is my y-axis. This is my y-axis. Now, what is moment of area? Moment about y equal to integral of y dA. So what I will do is I can take a strip here, small strip here. Very, very small strip here. This strip in the area dA. Okay. So why didn't I choose small square? It is simple. This strip in the area I can find very easily. Easy item. Other symmetric one. Shape symmetric item. I can take a strip. I can take a strip here. Okay. So let's say I'll take this. So this is x. This is x. Okay. And this very small distance is x direction line on it is dx. Okay. So my dA will be equal to dx is the width. Each area rectangle area width into height. Height is d. Okay. So d into dx is my small area. Okay. So what is my y? Y is integral of, so dA is d times dx. Okay. What is y distance? So distance is m of y is x integral d, x d. Okay. So what is the distance? So this x, ചെറിയ ഏരിയയുടെ മൂവ്മെന്റ് എന്ന് പറയുമ്പോൾ ഏരിയ ഇൻറ്റു ഡിസ്റ്റൻസ് അല്ലേ? ഈ ആക്സിസിലാണ് നമ്മൾ പഠിക്കുന്നത്. അപ്പോൾ about this axis, what is the distance? X. So area is dA. Area into perpendicular distance is x. So x into d into dx. So d into dx is dA. This is x. Now integrate here. Simple integration. I'll take d outside. Integral of x dx is x square by 2, 0 to. So what is the limit of integration? So that also right here. So this I have to integrate from x is equal to 0. So I take strips from here, this end to this end. X is equal to b. 0 to b integrate. 0 to b integrate എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഞാൻ ഇവിടെ ചെറിയൊരു സ്ട്രിപ്പ് ആദ്യം എടുക്കും, പിന്നെ ചെറിയ സ്ട്രിപ്പ് എടുക്കും, പിന്നെ ചെറിയ സ്ട്രിപ്പ് എടുക്കും, ചെറിയ എടുക്കും. I will keep on taking small strips up to b. Okay. അതിനെല്ലാം കൂടെ ഞാൻ ആഡ് ചെയ്യുന്നതാണ് ഇന്റഗ്രേഷൻ പറയുന്നത്. Right. So this is same as. So d I can take common. Integral of x ds is x square by 2. Limit is from 0 to b. So this is my moment about y-axis. So this is equal to, so I will substitute the limit here, d into b square by 2 minus 0 by 2. So this is db square by 2. This is moment of this rectangle, moment of this rectangular area about y-axis. Okay. Now I told you we can assume this to be at some point. So what is the area of the rectangle? Area of the rectangle is b times d. So I can centroid in this entire area I can assume it to be at some point. So I can remove all these things. Remove all these things. Okay, so this entire area in the rainbow, it is BD. BD is the area. Okay, it is located at some distance. So this distance I can write as this is XC, center in the distance. This is YC. Okay, so this both will have same moment of area about this axis. But we have already found moment of area of this diagram about this axis. This area moment of movement we have found about y-axis, right? So that is the value db square by 2. Now, what is the area moment of this area about this axis, the same axis? So we can write here m about y-axis is equal to area into perpendicular distance. So that means v into d is the area, perpendicular distance is xc. So I can equate these two. Equate here. So this gives me equating. This gives me xc into v into d equal to dv square by 2. Okay. So xc equal to, so I can cancel out v1 v cancel out, d cancel out. So xc is equal to v by 2. I think this you people know. Centroid b by 2 on e distance location. So this is b by 2. Okay. So how do you find the other axis, mx axis? So that is also same. The only thing is you have to take a different strip. Different diagonal strip. So for example, this way. Okay, so now we have to find moment about x-axis. Okay, so x-axis moment what I will do, I will take a consider strip in this direction. Okay, so let the strip be located at distance y, and the thickness of the strip be dy. Y-axis, so small change in y, dy. Okay, so my area will be dy times. So this area is dy times b. Okay. So in a moment about x-axis will be integral of y dA. That is the integral of the location is y into dA is b dy. What is the limit? Limit is y equal to 0 to y equal to d. ഇങ്ങനെ ഇവിടെ മുതൽ ഇവിടെ വരെ ചെറിയ ഇങ്ങനത്തെ സ്ട്രിപ്പുകൾ എടുക്കാം എന്നിട്ട് അതിനെ ആഡ് ചെയ്യണം അതാണ് ഇന്റഗ്രേഷൻ അല്ലേ. So this gives me b common എടുത്തു കഴിഞ്ഞാൽ y square by 2 0 to d. So this gives me bd square by 2. So this is mx. Right? നിങ്ങൾ നോക്കി കഴിഞ്ഞാൽ my യുടെ വാല്യൂ എന്തായിരുന്നു db square by 2 ആണ്. mx ന്റെ വാല്യൂ ആണ് bd square by 2. തിരിച്ചു കിട്ടി. Okay. Now we already know that what is centroid. അപ്പോൾ നമ്മൾ already centroid നമ്മുടെ mark ചെയ്തിട്ടുണ്ട്. We'll just take this figure. Okay. Now for this figure, what is the mx? Within the moment. So this area into perpendicular distance. So what is the perpendicular area? Is one point. So point down, it is easy. Point into perpendicular distance. So about this axis. So this is the area. Perpendicular distance is yc. So we can write this is area is b times d. The perpendicular distance is yc. So you would integrate in the because it is a point. Area full with a point light and value of area is b into d. So we have to equate these two, and you will get b times d times yc equal to pd square by 2. So if you cut, we will get yc equal to d by 2. Okay, so this will be equal to d by 2. That is the rectangle centroid b by 2 and d by 2. Within the half, depth in the half on a centroid point area. Okay, so this is about centroid of very simple diagrams. Now we have to find centroid of complex diagrams. Complex diagrams, so let's say you can get many type of problems. So let's say you have a so you can get a diagram like this. Okay, so common shapes in the centroid of I will give you a PDF on top. Circular centroid is in the center of the circle. Okay, a rectangular circle, it will be b by 2 d by 2. All those things you know. You can get complex figures like this also. So basically ഇതെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഒരു ഷീറ്റ് ഉണ്ട്, ആ ഷീറ്റിൽ ഒരു ഹോൾ കട്ട് ചെയ്തു. അപ്പൊ അങ്ങനെ ആകുമ്പോൾ അതിന്റെ സെൻട്രോയിഡ് എവിടെയായിരിക്കും. Okay, then we have shapes like this. Maybe something like this. What about centroid of this figure? Okay, you can find centroid of this figure also. There are many ways of doing it. So we will do one figure. We will take this problem and try to find the centroid. Okay, here we go to the centroid. Here. Okay, so how do you solve this? So it is simple. Only thing is okay. So this let's say I'll draw an axis. Axis that is very important. I'll draw an axis here. So let's say this is my first axis. This is my second axis because we are always finding centroids from with respect to a reference axis. So this is the x, this is the y. The x axis and the y axis. Okay. Now, how do I find area? So basically, in this area, concept number what we are seeing is regular figure number. This figure moment of area. Area, full area process integration. So basically, try to find small areas for which you know the centroid. Okay. This we can do in many ways. So one way we are doing is we will identify one area. So this is one area in which I can know the centroid. This area is centroid. There is another area that is this. These are two rectangles. So I can name this as this is my first area. And this is my second area. Second area. Okay. So we have to find centroid in both directions. But x direction, y direction, centroid. Regular divide areas convert it. So we have a rectangle here. We have a rectangle, right? So what is so let's say we will put some sizes. Numbers then it will be easy for us to calculate. So let's say this is 100 mm. Or this is 200. This is 200. Let's say this is 20. Let's say this is 100. Let's say this is also 20. Okay. So you will find usually we need to find the figure. Okay, this figure is centroid. So I told you we have to split into small areas. So this simple table form this is more easy. Okay, the table form what all we have to do. So let's say we'll find A. AI. AI is from 1 to 2. We put a guess there. AI. Okay. Idinte AI XI, then AI XI, then YI, AI YI. So just let me make the table. So your table it will be more systematic and it will be more easy. Okay. So first I will find the centroid of this figure. This figure with respect to the same axis. We carry on the axis, the axis. So I'll just calculate for this figure. Here figure assume to calculate. Okay. So what are the values that I know? This is 20 and this is 200. Okay. What is the area of this figure? So this is my first figure. Okay. I should have taken so this is I equal to 2. Or I will do one thing. I will change the numbering. Change the numbering. So let's say this is my second figure. And let's say this is my first figure. Okay. So I equal to 1. I equal to 1 first figure. The first figure we know what is the centroid of this figure. This figure the centroid. Okay. So this is my and the y1. Y1 at D height by 2 area. This is 200. Okay. Then this is my x1. X1 at 10. Okay. So what is the area? Area 300. My area E figure area that is 200 by 20. That is 4,000. Whatever units is there. The mm is mm. So this is let's say this is the mm. So this is let's say mm square. Okay, 4,000 mm square. What is the location of xi? Xi location of 10. Okay, this rectangle area is centered half. AI into XI, this into this I have to do. So this is also mm. So 4,000 into 10 is 40,000. 40,000. This is what is the unit? Mm cube. Area is mm square times mm is mm cube. Okay. Now what about YI? YI in പറയുമ്പോൾ is 200. 200. So area into YI is AI into YI. YI is the unit is mm. AI into YI is, what is AI? 4,000 into 20 is 200 is, so YI is 100. So YI എന്ന് വെച്ച് കഴിഞ്ഞാൽ total height 200 ആണ്, 200 half ലായിരിക്കും is centroid. So that is why it is 100. This is 20 to half and 10. Okay. So this will be 100. This will be 100. Right. AI into YI. What is AI? 4,000 into 100. So it is 4,000, 40,000, 400. So this is my first area. What about the second area? Second area also I can find now. So second area, it is a smaller rectangle like this. Okay. So this is my second area. What is the axis? I have an axis like this here. Where axis under? Pinner axis is here. Okay, same axis I have to use. And here axis axis same again. We have this distance here. This is x. Okay. Now what is this distance? This is 20 mm. What is this? 100 mm. What is this? This is 20 mm. Now, this rectangle centroid about this axis. Y-axis is rectangular centroid. So even we know what is the location of the centroid. So that is 50. You know, even it will be 50, and even it will be 10. So this is the centroid. So centroid will be 50 from this edge and 10 from this edge. Okay, and I equal. So how do you find the values? So let's find the area. AI, A of 2, area of second is 100 into 20. Okay, so that is 2,000 mm square. What is location of XI? So XI in the centroid of this XI, location of centroid in X direction. Okay, so even in the 50 and 20, so 50 plus 70, 20. Yeah. Equal to 70. So extend this. Okay. Now, so AI into XI, 2,000 into 70. So 2 into 4 is 40. 2, 3, 4. It is 1,40,000. Now what is YI? YI in the neighbor. E distance on YI. Okay, in the centroid Y direction of the centroid. So centroid location in Y direction. So from here it is 10. Okay, AI into YI, 2,000 into 10 is 20,000. 20,000. Right? Now, how do you find? We integrate oro area centroid add we get the moment of area. So total moment of area is basically, if you add these two, you get moment of area about. So AI into XI. What is AI into XI? So area into XI is basically moment of area about Y. So this is MY. This is MXI. Okay. So we add this to get area moment about Y equal to this plus this. That means 40,000 plus 1,40,000. That is 1,80,000. Okay. Now what about this? Moment about x equal to, we have to add these two. So this is 4 lakh plus 20,000. Okay. So we have found the moment. E full area we can assume it to be. So what is the total area? Total area equal to this plus this. 4,000 plus 2,000, 6,000. So this entire area, like 6,000, can be assumed to be at a located at a distance. So this is the area. Some point here. I don't know what is the point. This is the area. So it is located at some distance, that is the centroid in x along x, some distance along y, that is the centroid in y. Okay. So what is the moment of area? E diagram ഈ ഒരു പോയിന്റിൽ entire area ഉണ്ടെങ്കിൽ അതിന്റെ മൂവ്മെന്റ് about x എത്രയായിരിക്കും y x എത്രയായിരിക്കും y x എത്രയായിരിക്കും അതാണ് നമ്മൾ ഇനി കണ്ടുപിടിക്കുന്നത്. So this is my y, this is my x. Okay. Movement about y axis will be equal to 6,000 into x. Okay. And movement about x will be equal to 6,000 into yc. That is the area. Okay. So that means xc can be equal to my upon 6,000. My we already converted. So that is 1,80,000 divided by 6,000. ഈ ഫിഗറിന്റെ മൂവ്മെന്റ് അബൌട്ട് y ആക്സിസ്, ഈ ഫിഗറിന്റെ മൂവ്മെന്റ് അബൌട്ട് y ആക്സിസ് സെയിം അറിയാം. അതാണ് നമ്മുടെ സെൻട്രോയിഡിന്റെ കോൺസെപ്റ്റ് അല്ലേ? സെൻട്രോയിഡ് എന്ന് വെച്ചാൽ എൻ്റയർ ഏരിയ ഈസ് അറ്റ് എ പോയിന്റ് and still the moments are same. That is centroid concept. Okay. Or the entire area can be assumed to be at that point. Still, it will act in the same way. Okay. So 6,000, the area will divide either into equity and this I am equating. So that means I will get xc is equal to 1,80,000 upon 6,000. Xc and yc amount of money. So this is 300. Okay, and yc equal to 4,20,000 divided by 6,000. Okay, it is 70. So this is, I think this is 30. So 30 mm. 70. So centroid of this figure will be in x direction. It is we have to travel 30 mm. Okay. So let's say this is a centroid. I don't know what the centroid is. X direction I have to travel 30 mm. So this is 20. This is 100. 100. So 30 means 10. Some in this direction I have to travel in this direction somewhere here. Okay. And y direction I have to travel 70 mm. So this is 20. So somewhere here. So this is my centroid. Xc comma yc. Xc is equal to 30 mm, yc is equal to 70. So this is how we find the centroid of a composite figure. While you have to remember this, the concept is simple. Although area movement about this axis but the other equal to the entire area is at that location. Our area movement about this axis equity. I hope this is clear. Step by step I done it. So I think it is not a problem. There is another way of doing this. So that is what I want to discuss now. So we will not. I don't think we will have enough time to do that. But still, it also will help you. Okay, ചില സമയത്ത് നമുക്ക് ചില figures നമുക്ക് solve ചെയ്യാൻ അത് help ചെയ്യും. So how do you solve this?
That is what actually is. Water comes up from the matrix. So same technology.
Okay. There is another way of doing it. Another way. Yeah. We'll assume this full rectangle. Here, the full rectangle item, the first area, the full rectangle. So that is my first area. Okay. Then I will consider a negative area here. This was second area. Okay. But the full rectangle area. I the centroid, I the moment about this axis. This is a negative area. Okay. So I can do this also. So I think I'll quickly try to solve this. So let me see another way of doing it. Okay. So this is my first area. First area is the full rectangle. So we take the full rectangle. So what is the size? 20 plus 100 is 120. This is my X, this is my Y. Total, this is, how much is this? 100 plus 20 is 120. And this is 200. Okay. We figure the centroid now. We know what is the centroid. 60 and 100. Okay. So what is the area? This total area is basically 200 times 120. Okay. So this is basically 24. Then 0, 0, 0. 24 times it. Right? What is xi? Xi no x directional centroid, that is 60. Okay. AI into xi, 60 into 24. So 144. Okay, correctly. 24 into 6. Just take the calculator out. Okay, right. Now what about yi? Here figure the yi 100. Okay, so area into yi is 24,000 into 100. So 24 lakhs. Okay. The random area when we take, you have to be little careful here. This is my second area. Okay. Now my axis is original. Original axis and so that also I should be very, very careful. This is my axis. Okay. What is the dimensions? E dimension is 100. E dimension this is 200. 200 minus what is this dimension? This 20. Okay, so 200 minus 20 in the paper, it is 190. Okay, what is this distance? What is this distance? This distance is 20. What is this distance? This is also 20. Okay, now we know the centroid of this figure is here. That is even 50 and even it is 9. Okay. Now when we write area of this figure, when we write area of this figure, it is basically 100 into 180. But this is a subtracting area. So അതുകൊണ്ട് നിങ്ങൾക്ക് minus. Okay, so that means 100 times 180, you have to write as minus here because it's a negative area. Our area is negative area. Okay, so that is 180, 0, 0. Okay, so 18%. Now what is xi? X direction is centered at 50 plus 20. This is 50 plus 20. Okay. 50 plus 20 equal to 70. Right? Now what was area? 180 into 70. So this is 126 0 0 0 0. Right? So this is area into x. Area is minus. Area we have to write this minus here. Sorry. Okay. So this will be minus 126. Right. Now what about yi? Yi in the location is 90 plus 20. Equal to 102. Okay. Ai into yi is 18,000 into 110. 18,000 into 110, or it is 198 0 0 with a negative sum. Okay. So you find the total sum here. You find the total sum here. This രണ്ടിനും കൂടെ add ചെയ്തിട്ടുള്ള sum കണ്ടുപിടിക്കാം. ഏരിയയുടെ sum കണ്ടുപിടിക്കാം. So summation of area you find, summation of moment yi you find, summation of xi mxi. Okay. This is കണ്ടുപിടിച്ച് കഴിഞ്ഞാൽ what is പെട്ടെന്ന് ഇത് first time here. So 144,000 minus 126,000. This is equal to 18,000. Okay, we are getting 18%. So you see, we are getting the same value. 18,000. What is this area? So it is 24,000 minus 18,000. This will give me 6,000. 6,000. Okay, and this will give me 42, 4,20,000. Okay, so if you observe this table, the values are the same. Here 6,000 getting, 1,80,000 getting, 4,20,000. Okay, same thing. 6,000 getting, 1,80,000 getting, 4,20,000. So you get the same answer. Okay, so chela questions, it is easier to do this way. Chela questions, it is easier to do this way. Okay, so that depends upon you. Some questions, looking at the questions, it will be very easy to, subtract it easy. Okay, so don't mess up this minus sign and all, negative and minus. Area negative or automatic. So minus area into x minus minus area into what the value minus. Okay, so ultimately these two areas will be same. These two matches, this momentum, area same. Only thing is you have to make sure that you are doing it correctly. Okay, so these are two different ways. So I'll give you some assignments, some more assignments with regard to complex size figures. So like this, so I'll give you figure like this. Something like this, we can do that. You can find for figures like this. Okay, so lot of different possibilities are there. These are some of the common figures that we do. Right. So different figures assignment I'll give you to do that. Okay. So I hope this is clear. So I think just give me a moment. I'll take attendance and I'll give you.
Awesome.